So this is artificial intelligence, or what I like to call teaching computers to think. And you've all heard about artificial intelligence, or AI as I will refer to it, because it's been in the news a lot frequently. And really what we mean by that is we're trying to mimic human intelligence in computers. We want them to take data in, we want them to make decisions, identify patterns, and tell us stuff about the data that we have. On the right-hand side is an example of different types of AI that kind of fit into that AI umbrella. Machine learning is one you've probably heard of, computer vision, large language models, generative AI. All of those are types of artificial intelligence that you may have heard of. So, because AI is so popular right now, what you'll see is everybody's product, everybody's service wants to say it has AI in it. And sometimes that's true, and sometimes it's not. So this is what I like to call, is it fancy programming or is it really AI? You probably have a thermostat in your house, I hope so. And maybe this thermostat is one where you can program it to change temperature when you go to bed or when you're away at work. And it does that. You could have it on different days of the week, do different things, but it does that in a very deterministic method where it's always doing the same thing every day that you programmed it to do. You may have a different type of thermostat, like a Nest or an Ecobee, and that thermostat can learn from your patterns, like you left the house today, so now it knows you're away and it can change the temperature. So it's doing that based on your actions and what it learns over time, and it's adaptable. So the one on the left is just fancy programming. The one on the right is actually AI. And we see AI all over the place now. A lot of it in our homes, just like that thermostat. If you have a Ring doorbell, or you have a smart speaker, if you have lights that can dim themselves, if you say make it brighter or darker in the room, all of those are examples of components that have artificial intelligence in them. We also all have phones, I'm sure, except my son, who refuses. But those phones have got virtual assistants on them, like Siri, Google, or Alexa. And you can ask them to do things, and they're using something called natural language processing to understand what you say and either reply to you or do some kind of action based on what you asked. Or sometimes, for me, when I ask Alexa to do things, she does other random things that I didn't ask her to do. So AI is not always perfect. If you have a credit card, your credit card company uses your patterns that you do over time. So if you always buy things in Texas, then it knows you always buy things in Texas. And if something happens in Florida, you may get one of those alerts on your phone that says, hey, did you really do this in Florida? It's using your patterns and using AI to detect those things. Or if you watch Netflix, Hulu, any of those other things, or listen to music on Spotify, it's using your past likes and watches to determine what you might like to watch in the future. And again, I mentioned AI is not always perfect, right? This is my Netflix, where I actually would watch the Barbie movie, but Squid Game, never. So why is AI so prevalent right now? A couple of years ago, large language models came out. ChatGPT, Microsoft Copilot, Claude, you may have heard of. And those things were trained on large bodies of data, like the internet or scholarly articles, or other data that we don't even know that they use to train on. And what they do is they've used all that data to make themselves really smart at interpreting data and determining what a response to the data will be. And they're hugely, a huge boost to your productivity. So they can take large documents. You can give it a few hundred pages of documents, and you can say, tell me, summarize this, and also tell me why it's important for me. So if I give it something, I can say, what should Southwest Research Institute do with this information? And you can glean insights from the data that way. They also can help you brainstorm ideas. So if you've come up with some things and you want to know whether maybe you missed something in your ideas, if you feed that into the GPT, it can look at that and it can say, oh, have you considered this? Or how have you done that? And you can actually do the chat GPT that you can use the voice one. I actually talk to it on my way home from work sometimes, and we just have a chat like it's another person. So, and you can actually learn some interesting things doing that. It also helps us to enhance our communication, right? It can translate between one language and another. It can translate computer languages. But more importantly, it can translate your message to different audiences. And I'm going to show you an example of that. Say you have an artificial intelligence project that you did, and it's doing traffic incident prediction. So it's trying to determine where on the highway a crash might occur. For a technical audience, you would put a lot of jargon in there, like we're going to use neural networks and hyperparameters and things like that. But say I wanted to give that same information to school children. Well, then it tells me I should use some analogies that kids know about, right? So treat this like a traffic fortune teller, and it can predict, what's going to happen. And that's very relatable then to those students. Or if you had board members or other decision makers, you can change that so it says, oh, you should point out what are the real world benefits and examples that come out of this. So if you look at this, it's saying it improves safety, reduces costs, all things that decision makers would be interested in knowing about your product. So at Southwest Research Institute, we've been using artificial intelligence for a long time over many projects. One of the early ones, probably over a decade ago, was advancing autonomous vehicles. And that's using computer vision to detect other vehicles on the road, determine what signs are, find out where pedestrians are. Another example is we have launched an internal research program on large language models because that's very disruptive technology. And we want to know how we can use it to help our customers. So some of the projects we've done so far are taking things that are complicated, like giving commands to a robot to do things, and let's put it so you can just give it text and it knows what to do with the robot. Or you have a set of documents that you want to be able to access, like we can access the things on the internet. We put something together to look at our documents and give us information about our documents. Another area we're working on is using computer vision for biomechanics. And what this can do is help you improve outcomes, both for like athletes or even think about surgeons. People that are doing actions over the day, you can look at how the star performers are doing things and capture that data. And you can compare that against other people or even against your own data and figure out how you can improve the outcomes. Another area, which Prativa will hit on after the break, is medical diagnostics. This is a project we did that won an award helping radiologists detect breast cancer. So this is showing them where to focus on those screens they're looking at in order to pick out the areas that might be problematic. Or if you think about in industry where we have people that are in hazardous situations, how can we use robots to protect the humans? So you'll see right here, even the robots are protected, right, with a protective covering. But if I were a human in that situation, I would need like a mask and something to filter out those hazardous materials that are in the air. In this case, if we can put robots in place, we can protect humans. Now, with all the talk about AI, I mentioned that it's not always perfect, right? So there are some things we need to improve on artificial intelligence. One, if we don't have the right data or we're not using the data properly, we can make the wrong decisions. And one of the ways we can protect against that is to make sure that we tell people why and how we're making the decisions with AI. So explainability and trust are big ways to make AI safer. And then humans are just amazing. Our brains fill in details. We have a lot of contextual information. We look at things like body language to make decisions that AI doesn't have. If you look at the picture of the dog there, you can see by the body language with the ears down and kind of pleading, he's begging for food or attention or something. That's something that we don't necessarily have in AI right now. Another thing is like contextual information. A green light can mean a lot of things. It's on a camera back there, it means the camera's on, right? If it's on a traffic light, it means we should be driving and moving through the traffic light. So AI needs to be able to take those same contextual and situational awareness things that we take for granted and be able to do that. Right now, it's going to rely on its historical data. So if you put it in a new situation with new context, it's not as agile as we are. This is an example of driving on icy, snowy roads, which I know we don't do much in San Antonio. And if we have any of that, all the roads are closed down. But if you were driving on a road, if you have experience with that, you know that like the ruts or the clear areas of the road are actually really the slippier areas. And you should drive on where the packed snow is. And sometimes we pick up on that information by watching the car in front of us kind of its wheels slide a little bit. And again, that's contextual information that we're filling in along with our long experience of driving on icy roads. I'm from the north, so I have some experience. So I'm going to leave you with these quotes about AI. If you go look for people talking about artificial intelligence, you'll get everything from AI, it's old hat, to AI is going to solve all of the world's issues, to AI is going to bring down the world, and everything in between. So any questions?
Thank you. Right here in the front.
My biggest concern about AI is how the potential for corruption of the grand database could occur. What do you see how to prevent that? How do we better vet the information being stored?
So your
So
question
let me repeat.
alludes to,
Oh, go ahead. You can repeat it, yes.
your question alludes to the data problem is how do we make sure that the data that we have is good and doesn't get corrupted? There are some problems with that inherently in that there's a data drift kind of tendency that AI has, where if you feed it the same data, you can get it over-biased. So that's one of the areas to look into to be able to make sure we're not using the data incorrectly. And then, also that explainability factor, where you show people what you're doing with the data and how it came up with the decision can help you know that it's done the right thing.
All right, I think that's going to do it. Thank you so much, Lynn. Very insightful.